Anyway, we're gonna move on to something that's gonna be important for us, practically important here. This is a nice formula, ladies and gentlemen. Okay, so what you guys are seeing, this is a triangle. Is that true? Right? Is that true? This is a triangle. And remember something about every triangle here. What's the distance on the bottom known as? Right? This is called the distance on the bottom is known as your what? This is as your base. Is that right? B stands for base. What does that mean? That's just the distance. And what I drew here is sometimes called the altitude. You see this picture? This is also your height or your altitude. Is that right? So do you guys happen to remember what is the formula for the area of a triangle? Do you guys remember that formula? What is that? Isn't that 1/2 what? Base times height? Do you guys remember that? That's your formula for area of a triangle from geometry. No, this is not a circle. It's a what? It's a triangle. Do you guys remember this? Now, here's what I'm going to do here for you guys. I'm going to do the following here. You guys are going to, I'm going to put here, well, here's what I'm going to do here. I'm going to put an angle theta here, and we're going to call this distance down here A, and this distance up here called B. Okay? So what I'm going to show you guys is we have another formula here based on what I just showed, just based on what I wrote down. That my area is 1/2 AB sine theta. This is for any triangle here. Does anybody know why we can say that here? Do you guys know why we can say that? Really simply here. All they did is replace, you see this B here? They replaced B with what? With the letter A. Okay, you guys okay with that? That's all they did. This B is now the A down there. And then you say, well, where did they get the H from? Where do you guys think H came from? See this H? Where did H come from? Anybody know? Well, tell me, if you look at this picture, how do we define sine theta? What is sine theta from this picture? Sine theta, here's my theta. What's the definition? Isn't it opposite over what? Hypotenuse. Is that true? So sine theta is H over what letter? B. I want you guys to see that here. This is where this is the important part. Sine theta is opposite. It's the h in your triangle divided by that hypotenuse. So then that means that h will be, solving for h will be what? B sine theta. Got some nursery rhymes? That's kind of nice to wake up to. Is that right? You guys know what I mean? Did somebody bring their baby? Oh, we should answer it, huh? Wonder if YouTube's gonna flag me for a song that no copyrights to. Where did she go? It's all right. You don't have to go chase her. Well, here's your h, ladies and gentlemen. So replace that h with what? B sine theta. That's all. Right over here. And so, ladies and gentlemen, that's the deal. We just proved this area formula. So what I want to remark, though, is get rid of this. This is what we've shown. So now you can find the area. This is going to be a big deal for us in our future. So they like to give you guys some kind of examples here. Okay, they'll say just determine the area. Let's say this is 12 centimeters. This will be 10 centimeters. And your angle will be 32 degrees here. So notice you must be given this. You have to be given that length and this length. And this angle. You have to have that picture. And I want to let you guys know, this is known as side angle side. Okay, for a triangle, right? So you got what's called side angle side. What's your area? 1/2 times 12 times 10 times sine of what? 32. And you're going to use this area formula. Okay, so let's do just a little bit of arithmetic to make this a little bit easier. I'm going to say 12 times 10 times sine 32 divided by what? 2. Okay, so you might say, what did I do here? Well, I mean, I can also do what? Do you guys know what we can do? We know a little bit of arithmetic, right? What's 1/2 of 12? 6? And what's 6 times 10? 60? So we can kind of do a little bit of arithmetic. We can just say, hey, that's 60 sine of what? 32. So now in your calculator, if we're set to degrees, hopefully we are. Let's go down here, go to degree now, ladies and gentlemen. So that'll give you 60 sine of what? 32. So you get now 31 point what? Let's go to the tenths. 31.8. 31.8 centimeters squared. And that's that. So we're just going to use that area formula. And this is called side angle side, by the way. Right? You say, why is that called side angle side? Because you have a side and an angle that's between two sides. Okay, so this is a side angle side situation. It doesn't matter. If the angle here, let's say here's 50 degrees, here's 4 units, and then here's maybe 8 units. It won't matter because we say here's going to be the side they gave us, the angle they gave us, and another side. Let's just keep the word unit out. What if she never comes back? We gotta listen. I gotta listen to this all day. She doesn't come back. I hope. It heard me. Wow. In honor of Halloween. Scary. This is a side. This is an angle. This is a side. So I just want you guys to get used to that idea because that's where we're headed. Side angle side, meaning there's an angle between two adjacent sides. So anytime you have this, you could use this formula. This formula is new. This formula is brand new for you guys. I just proved that to you guys. 1/2 AB sine theta. You know, area formula for a triangle. So when you write it down, you say, can I put 1/2, pick any side, it doesn't matter which one, 4 times 8, and just take the sine of now what? 50 degrees. So that your area now will be, you can do just a little bit of that arithmetic if it's possible. If you have, sorry, this is supposed to be, 1/2, 4 times 8. You got 2 even numbers. So what's 1/2 of 4? Isn't that 2? And then 2 times 8 is what? You get 16 sine of 50 what? Degrees. So now we just have to take what? 16 sine of what? 50 degrees. What do you guys end up with? Going to the nearest tenths again. 12 point what? 3. And that just is generic units. So we just say units squared. 12.3. So just want to kind of share that new area formula with you guys. Side angle side. And then, they can give you some words here. They can say, find the area of a triangle with sides of lengths 3 inches and 7 inches and an included angle of 68 degrees. Okay, so take a look at that. Was there really a person here? So what do you think we have to do, ladies and gentlemen? Just draw a triangle. Put 3, put 7, and look at the language that they use. What do they mean by included angle of 68 degrees? They just mean that that is between the what? The lengths. That's all they mean. So you have, again, side angle what? Side angle side. So your area is going to be what? 1/2 3 times 7 times sine of 68 what? Degrees. So now with your arithmetic here, you might want to say, what's 1/2? That's going to be what really? Isn't that 21 over 2? Sine 68 degrees. You guys happen to know what 21 over 2 actually is? Is that 10.5 as a decimal? Okay, so they gave you some language, included angle. So, all right, let's do some arithmetic here. Get out the calculator, 10.5 now. Sine of what? 68 degrees. What do you guys get now? 9 point what? 7. So this is approximately 9.7. And I guess they gave us units that were in inches, so we have to put inches to the second power. And there you go, ladies and gentlemen. There it is. Yes?
How did you know what side to...
Oh, good question. How do you know what to label 3 and what to label 7?
Yeah.
Well, I really didn't. I just drew a triangle, and I put the shorter side as 3 and the longer side as what? 7. Now, you might even say, why did I put this as 68? Well, I could have put it over here, but if I did that, I got to move this over where? There. Because we got to have this situation. You say, what situation? It has to be side angle side, where the angle is between two adjacent sides. All right? That's why they use the language included side. That's really what that means. So I just want to remind you guys, we could have done that too. Okay? And they just gave you words. One question, or actually a couple of questions, that I really think are interesting. If I could get it back, I just... kind of get it back. It's hard to come... Let's give you guys this question, see what you think. Here's kind of a good question here to give you guys. See what you guys think about this one. This is only for those who are awake. This is 3. This is 3. This is 125 degrees here. And let's see if you guys can figure this portion out. What is the shaded area? How do you guys find the shaded area? You guys know? How do you actually deduce this? And what does this even have to do with what we just talked about? Anybody know if I said this to you? What's the orange region known as? Well, that's area, but what kind of shape is that? This is a what? In orange, isn't that a sector? The orange portion? Say yes. What's the area for a sector? What's that formula? 1/2 what? R squared theta. And theta has to be in what? Radians. Do you guys remember that one? Okay. And then I'm going to say this to you. In blue, what is this going to be? What's this? Is that a triangle? Okay, and blue is a triangle. So I'm going to write this down. You also have a what? Triangle. What's the area here? 1/2 AB sine theta. Is that right? Did you guys see my point? So what is the point here? Area in this picture is going to be the area of a sector minus the area of a what? Triangle. One half R squared theta minus 1/2 AB sine theta. And let me actually keep it that color black because you guys can see it. That's the shaded portion. So you might say, do I have to find 1/2 R squared theta minus 1/2 AB what? Sine theta. So ladies and gentlemen, area of a sector right in here minus area of a what? Triangle over here. Okay, let's write this stuff down. 1/2. What is R in your sector? Is that 3? Okay, so that's going to be 3 squared. What's the angle? 125 degrees. But it has to be in radians, so you put pi over what? 180. That needs to be in radians. You guys remember that homework? Okay, minus 1/2. Now what about the triangle? Isn't that 3 times 3? And then that's going to be what? Sine of 125 degrees. So I want people to really look at this and say, is that how you find the area of what? That shaded portion? And the answer is yes. That's what you want to do. So that's how we find it. So it's the sector, and yet it's the area of the sector, and then they threw out the triangle. That's why they subtracted. So you can simplify with the arithmetic and say, I got 9/2 times 125 times pi over 180 because the degrees cancel, minus 1/2 times 9 sine 125 degrees. Now, we can say 9 times 125. Do you guys happen to know what 9 times 125 is? Looks like it'll be 1125, right? So we'll put 1125 pi divided by 360. Where did that come from? Numerator, see that? Down here? Minus 9/2 sine of what? 125. So you want to punch all this in your calculator to get that area of that little portion here. So let's punch that in, right? So here's what we say here, okay? 1125 times that pi. Pi is over here. You guys remember that? Divided by 360. Is it kind of interesting that maybe you have the same calculator, right? And what's 9/2? Isn't that 4.5? This is still in degrees, 125 degrees. So I entered everything you have here, but what I also said in the calculator was, I know what 9/2 is. 4 point what? 5. This is what's in my calculator. So let's hit enter. And what do we get? 6.1. If we go to the tenths, I like going to the tenths. 6.1 what? Square inches, ladies and gentlemen. So I want to share with you guys this very, very special kind of question on finding the area using some of these tools that we talked about here. Okay, we already know how to find the area of a sector. Now we have the area of a triangle, and we can actually do what? Find the area of that little portion there, ladies and gentlemen. So, okay. So I did put some area area questions on your homework in 6.3. So take a look at that, try those out, and we'll see you guys when? Tomorrow. So take care.